finish this section on modeling and applying what we know about algebra and solving equations, we're going to look at some examples that are a little bit more realistic to have a little context to our equations and our modeling here. So if you look at this question, it talks about a car, value of a car. When purchased in 2003, this car had a value of $80,500. Depreciation may not have experienced that yet, but basically, you ever heard when you drive a car off a lot, it's losing value. The depreciation on this particular car is $8,705 per year. Depreciation can be modeled in different ways, but basically, you're losing that much value every year on the car. Says after how many years will the car's value be $19,565? Well, remember when we're doing equations, and you may want to stop the video, try it on your own, and then compare to what my answer ends up being. But if we look at what we don't know, this is what we want our variable to be. And generally in the question it'll ask you how many years, ask for a specific quantity, and that's generally what our variable wants to be. So x is going to be, for us, the number of years that have passed by. If we want to model how much the car is worth, well, we want to know when's the car's value going to be $19,565. So if it started at $80,500, says it's losing $8,705 per year, that'd be $8,705, and then per generally means to multiply. So if it's depreciating, that's how much value is being lost each year. So to solve this, figure out how many years, do your basic solving steps, and you should get that the number of years we were to solve, the number of years in this case when we get to that specific value, assuming we don't want to just count down every year, we just want the answer is going to be x is 7 years. So when we're answering a question like this, we want to make sure we're giving it context. After how many years? It's going to be 7 years. So make sure you can model this equation or model this situation using an equation. That's the idea of this section in particular. Other situations, this is kind of a common one you might see with maybe a cell phone plan. In this case, you're choosing between two health clubs. One says offers a membership fee $40 plus a monthly fee of $25. The other club is $15 plus a monthly fee of $30. So isolating the information from Club A and Club B, says again how many months. So pause, try and come up with the equation on your own, and then compare to what we come up with here. But if we have how many months, it's asking for that value x, or if you want to use the letter m, something that matches your situation, our variable is going to be the number of months. So when will the cost be the same? So Club A, it says $40 to join plus a monthly fee of $25. So that means every month I'm going to be paying $25. So $25 times that variable. Club B, I want to know when are they equal. So I want to compare Club A, see when Club B is equal to that. So it says $15 plus a monthly fee of $30. That'd be 30 times the number of months. We're using the same variable. It's talking about the same variable in both situations. So if we solve this, we get that the number of months would be 5. So at 5 months, they should be the same cost. And the second question says, how much would it cost? Well, if we plug that back in, after 5 months at Club A should be the same cost as Club B, and it should be $90. I'm going to try one more problem together here. and then I'll leave you with one to attempt. So it says, after a 20% reduction, you purchased a television for $336. So this is your end price, what you actually paid. It says, what was the TV's original price? So again, the quantity we're looking for, the TV's original price, that's going to be our variable. So X is going to be the TV's original price. So if you think about how you do a discount, if I told you were getting 20% off of the TV and I told you the TV was originally $100, let's say the original price was $100, you'd find 20% of that by saying 20% or 0.2 times that number, and then you'd take your original price and you'd subtract away that $20 to find your new price, your final price, your purchase price. But in this case, we don't know what this value is, what this starting price was. So we have our variable here. If we were going to find how much the discount was or how to take the discount away from there, we start with our original price. If you look at our $100 here, that was our original price minus, and how did we find this $20? Well, we took our original price and we multiplied it by that 20%. That's equal to our purchase price, which we know to be, from the problem, $336. So this is a little bit different looking problem, but just remembering the place to start is, what is your variable? If I take x and I subtract away 0.2x, I'm left with 0.8x. Divide on both sides to get my original price, and my original price should be $420. You could double check that by saying, okay, what would a 20% discount on that be? Well, if I did 420 times 0.2, that would be $84 in discount. 420 minus $84 in discount sends you back to that price that you said, or that we said, and we paid $336. So just to double check our answer there. The last problem I'm going to leave you here with, I'm going to start kind of illustrate it for you, but it says a soccer field is twice as long as it is wide. So if we got a soccer field here, you have a length and you have a width. If the perimeter of the soccer field is 300 yards, what are its dimensions? So the key piece here is this description of the field. It's twice as long as it is wide. So what don't I know? This one's a little bit trickier. What are its dimensions? I don't know its width and I don't know its length. Let's say I'm going to set, though, I need to pick a variable. Let's say I say the width is equal to x. Then what's the length equal to? Well, it says it's twice as long as it is wide. If the width is x, then the length must be 2x. This is where I'm going to leave you. Oops, sorry. That's not part's not 2x. Width is x, length is 2x. It says the perimeter of the soccer field is 300 yards. Using what we just came up with here, I want you to try and finish this problem. Remember, we're trying to model using algebra. More efficient 99% of the time than guessing and checking or going through kind of a longer process. So bring this to class tomorrow and we'll talk about this particular problem and more.